Alright guys, today's goal, the learner will understand complex zeros and the fundamental theorem of algebra. Well, you'll learn about two major theorems, complex conjugate zeros, factoring the real number coefficients. Why? These topics provide complete story about the zeros and factors of polynomials with real number coefficients. A polynomial function of degree n has n complex zeros, real and non-real. Some of these zeros may be repeated. So if you have something like this, there are potentially 5 complex zeros, whether they're real or non-real. Okay? If f of x is a polynomial function of degree n is greater than 0, then it has precisely n linear factors, where a is the lead coefficient of f of x. Okay? Z1 are not necessarily distinct numbers, some may be repeated, so you can repeat. For example, if we have x squared minus 16, x plus 4, x minus 4. See, they're not the same. They're different numbers. And there was, see how n was 2? There's 2 linear factors. Those are 2 linear equations, okay? So, that's what they're talking about. Fundamental polynomial connections in the complex case. The following statements about a polynomial function f are equivalent if k is a complex number. Okay? Number one, and complex numbers are a plus bi. Okay? X equals k is a solution or root of the equation f of x equals 0. So, yep. K is a 0 of the function, and x minus k is the factor. Okay? Example exploring fundamental polynomial connections. Write the polynomial function in standard form. Identify the zeros of the function and the x-intercepts of the graph. So the zeros are the x-intercepts. So what would you say? To get the zeros, you do this. You go 0 equals x minus 3i, 0 equals x plus 3i. So you get x equals 3i, negative 3i equals x. So there are the zeros. And now we got to multiply it out. So you get x, f of x, equals x squared plus 3ix minus 3ix minus 3i squared. Those cancel out, so you get x squared minus 3i squared, 9. 9. So that should have been minus 9i squared, 9i squared. But what does I squared equal? Negative 1, so this would be x squared plus 9. So there's the standard form. Okay? Yep, and because the zeros are not real, the graph has no x-intercepts. If they were real, those would be the x-intercepts. Okay? So yeah, we did get that right. Suppose that f of x is a polynomial function with real coefficients. If a and b are real numbers, with b not being 0, and a plus bi is a 0 of f of x, then its complex conjugate is a minus bi. So the is also a 0. So 5 minus 2i, what's the complex conjugate of that? 5 plus 2i. Okay? Just making sure we know. If I had 3 plus 8i, what would the complex conjugate be of that? 3 minus 8i. Those are the complex conjugates. Alright, example of finding polynomial from given zeros. Write the polynomial of minimum degree in standard form with real coefficients whose zeros include 2, negative 3, and 1 plus I. Alright, so we know that we got x equals 2, x equals negative 3, and x equals 1 plus I. But we also know, we just said it's the complex conjugate. What's the complex conjugate of 1 plus I? 1 minus I. So there's all the zeros. So the first thing I would do, subtract that. So I know I'm going to have x minus 2 times x plus 3 times x minus 1 minus I times x minus 1 plus I. So this first one, x squared plus 3x minus 2x minus 6, that would be x squared plus x minus 6. Now I'd do these two. X squared minus x plus ix minus x plus 1 minus I. And I gotta get in here. Minus ix plus I minus I squared. So I have x squared, then I have negative 1x minus 1x, so minus 2x, and then ix minus ix, so those cancel out, and then 1I minus I, and then I have the plus 1, and that would be plus 1 there, so you would get x squared plus x minus 6 times x squared minus 2x plus 2. So now we have to distribute all these and combine like terms. So x to the 4th minus 2x to the 3rd plus 2x squared plus x to the 3rd minus 2x squared plus 2x minus 6x squared plus 12x minus 12. Combine the like terms. X to the 4th. Negative 2x to the 3rd plus, so minus x to the 3rd. 2x squared minus 2x squared is 0. Oh, there's still that minus 6x squared. 2x plus 12x, 14x, minus 12. So let's check to see if we're right. And we are. Okay. Factors of polynomial with real. Every polynomial function with real coefficients can be written as the product of linear functions and irreducible quadratic factors, each with real coefficient. Alright. Write f of x equals 3x to the 5th plus x to the 4th minus 24x to the 3rd minus 8x squared minus 27x minus 9 as a product of linear irreducible factors with real coefficients. So you can use synthetic division or use your calculator to find one of the zeros, and one of the zeros is x equals negative 1/3. So now start with synthetic division. negative 1/3, 3, 1, negative 24, negative 8, negative 27, negative 9. Okay. So bring it down. Negative 1/3 times 3 is negative 1, so that'd be 0. So 0, negative 24, 8, you get 0. So that'd be 0, negative 27, you get 9, you get 0. So let's see, I would have, this would be 3x to the 4th minus 24x minus 27. Now I know I can factor out a 3. I get x to the 4th minus 8x. Oh, but that's squared. Minus 9. So what multiplies to 9 and adds to negative 8? Negative 9 and 1. We still have the 3. And this 1/3 here, that's x plus 1/3. So we got to remember to add that in at the end. Now, can any of these still factor? So now we got to check, can we still factor more? This one, yes. So you have 3, x plus 3, x minus 3. And then we got to bring down the x plus 1/3. So product of linear and irreducible quadratic. See, that's you cannot simplify that. So there's your f of x. So let's see if we're right. Yep, same order, just different. And see, they use synthetic division, so you could have done, or you could have done the calculator to find 1, 0 and then do it. So, but there you go. I will see you guys in class tomorrow.